Afterwards, we will explain why the SQL standard is not turning complete and what are their consequences. So today our main focus will be to learn the relational set theory and what are the SQL queries that we should understand and what are their meanings. So getting start with the advanced relational database concept. So what here the relational set theory is the foundation of the relational database. The question is how it connects with the structure query language. Structure query language is a type of language that help us to perform the CURD operations, means how we can create a database, how we can update our database, how we can retrieve the data from the database, and or how we can delete any information from the database. So that is the CURD operation. So that's what a structure query language will help us to do. The question is how the relational set theory is connected with it and what is it? So it is a mathematical concept. It involves the entities, relations, and operations that are used to manipulate and retrieve data. Now, what are entities and relation? Let's see that in detail. As I mentioned that it is used to retrieve the data in the database. The first one is the entities and classes. Now, what are entities? It can be anything that is related to the real world. It can be a non-living thing. It can be a living. Anything means to represent things or names, anything, whether it is an object or a concept. We use the word entity in databases. What is entity? Entity can be a student, entity can be a thing, entity can be a place, entity can be any organization. So anything that is related to real world will be represented as entity in database. So it models as row. So entities are written in the form of rows that are known as tuples in database table. So you have to remember these things because in future when we will create database, these things will be very helpful for you because these are the core concepts of advanced database. Hope so you have learned these things in your previous course. Now what are classes? Now classes represents the collection of similar entities. For example, we have an entity that is student. Now the class student contains the related information of the student. It can be the student ID, it can be the student name. If I ask you to create a class of the student in which you enter all the properties of the student. So what is a class? Class is the collection of similar entities that is modeled as a table. So in database, to present similar entities, we use the term known as table. So let's suppose if we want to create a school database. So what can be a specific entity? It can be a student, it can be a teacher. If I talk about the properties of a student, it can be the student name, age, class. So the class could be students table containing all students. Means where all the students are present, that could be a class. So we can name that class as students. So let's understand like this. So this is a table. Okay. So in database, this is how the data is stored. So we want to arrange the student table. So the class is students. Okay. Where we have the student ID. So where the class can be the students. So we have student ID, we have name, the age. So this is how a table is created in our database. The second thing that I explained was the tuple. Tuple is a single row in a table, just like this. So here, one tuple can be this one. This single row is a tuple in a table, this one. Student ID is 1, the name is John, and the age is 50. So this is the tuple. So what is a tuple? A single row that is mentioned in a table is known as tuple. After that, we have relation. Now, what is a relation? Means a table that contains the tuples that shares the same attributes. Like for example, only the student age 16 filter the tuple. Means for example, we have two tables. Table 1 for teacher and table 1 for, let's suppose we have two tables, one for excellent student and one for average student. You created two tables in your database. Now, in the excellent table, we have a student named John, and in the average student, we have the same name John for average one, and their age is also same. So, these two things are related with each other because their name and ages are same. Maybe their courses are also same. So that is a relation. This is what a relation means, that if two tuples, whether in the similar table, whether in the separate or other tables, are related with each other, they forms a relation with each other. Now, another thing that is very important here is the predicate. Means the conditions or the rules that we will define which tuple are included in a relation. Means predicates, you can take it as a rule. For example, I apply a rule that only students age 16 will be added in the table. So for example, I want to search the students in the student table whose age is 16. So this is a rule that I applied, and what the table will do, it will filter the tuples to include only the student whose age is 16. So this is the example of predicate. Predicate means the rules that we are going to apply to any tuple. What is tuple? Tuple is a single row in a table. What is a table? Table is the collection of entities. And what is the classes? Classes is the collection of similar entities. Hope so these things are clear. Then another most important thing is the relational operator. Now these operator extract and manipulate specific data. Now for example, you want to select a specific column from a relation. So what query you will perform? You will write select. This is the syntax for SQL. You will write select. What is the name that you want to select? For example, the name is the, you want to select all the name from the student table. Let's suppose you want to select only the name column. So you will write name. For example, I only want to select the roll number column from the table. So I will write roll number here. So this is how you can write the query. Then I had explained what is a tuple. So single row in a table, we know that a tuple. So what is a relation? A table containing tuples that share the same properties. So we have discussed that. Now for example, and what is predicate? Predicate means the rules that we are going to apply. So if I want the student whose age is equals to 16, so this is the result it will go give us. It will give us the result. The name of the student whose age is 16 means it will give us the complete tuple or a row of that student. So this is the query that you can apply. Like you will write. Now another thing, the select. Now every time we write a query, we used to write the select keyword first. So what does it means? So select is used to select a row that satisfy a condition. Means you want to select a specific row according to your condition. For example, you want to select the students where the age is equals to 16. So how you will write? First, we used to write select. Then steric is for represent from the table, from the all the table, means all the entities that are present in the students table. What is the condition? Where the attribute age is equals to 16. So this is how you can gather your information. Now you might think where these things are going to implement. How we are going to implement that? When you create your own database by using any database like Oracle, SQL, MongoDB, or if you create a fake, like for your test, you want to create your own test scenario, you download Apache friendly, you create a SQL server for yourself, SQL database for yourself. When you actually write the code and you want to retrieve the data, you want to connect your website or whatever it is application, if it's an Android application, you want to connect your data with your Firebase database, then these queries are used. Like you want to present, let's suppose you have created a school database. Now the application is something like this, that whenever the student enters their roll number, it will give them the result. Now, how the result is presented to the student. So these three things are connected with each other. Like if I explain the scenario here, this is the application. Let's suppose the application that you have created. This is how it is connected with the database that you have created, whether it is a SQL database, whether you created in MongoDB, or if it's Android, whether you created in Firebase. This is your DB that you have created. It can be a school database, so it can be a table for where the result of the students is stored. So this is the end user who wants to access his result. So it will enters the roll number here. Now maybe here you have write your internal logic. Means here the SQL queries are written in the middle. So here SQL queries are written, and this is the UI interface that is presented to the user. So here the user enters the roll number. In your backend programming, you have write the query, select static from student where, or you will select result. Here instead of static, you will write select result from the student where the roll number is equals to this. So if the roll number, if you can also apply the condition here where the entered roll number is equals to match with the specific roll number in the database, then give the result back to the user. Otherwise, say that result not found. So this is how the application, the SQL, and your DB is connected with each other. These things whole makes an application. This is how the things work at the backend. So where you encode your queries, when you create the program or code of your application, when you want, when you at the end, when you at the last you have created your own database and you want to connect with your application, then at that time these SQL queries are written. Okay, so the selection operator is used at the very start where you want to select the row according to the condition. So what are predicates? Predicates are rule that you can apply. Select is used to select the specific row. Then we have studied about tuples and tables. Hope so everything is clear till now. After that, if you, let's suppose, if you want to change the attributes, let's suppose you mistakenly entered a wrong name and you want to change it. So let's suppose you have write the wrong spellings. So you can write that select name as the student name that you want to write. You will write here from the student's name. So this is how you can rename or change a specific entity. Then after that, we have set operator. So what the set operator do? If we talk in terms of mathematics, we have multiple set operations. We have union, we have difference, we have Christian product. So these are the three operations. So what the union will do, it will combine two relations and it will remove the duplicate. For example, you want to remove the duplicate. As I mentioned that there can be two students whose names are same. So the union operator will remove the duplication. How? It will keep the, now I told you about primary key. Primary keys are used to uniquely identify the tuple in a relation. Means the primary key will define that the uniqueness of the whole row. So basically, just like your roll numbers or your IDs are unique, no one can have the similar ID. So similarly, if we talk about in the terms of student table, the student ID plays the role of student primary key here. So when you perform the union operation, so what it will do, it will remove the similar name but keep the primary key or the student roll number just for the sake of uniqueness. So you can write select name from students, then the syntax is you will write union like this, select, then a specific name that you want to unify from the all the rows that you have available. So this is the syntax that you can perform. Then difference. So what is the purpose of difference here? So just like union, what the union will do, union will find, eliminate the duplicate one. The difference will find the tuples that are not present in the other. For example, you want to select the name from the student except the selected name from the graduates. You want to select all the students, but you don't want to select the students that haven't passed the examinations. So this is how the difference can work. You can use the difference operator for this purpose. Now, for example, if you want to combine each row from one relation with another, for example, here you want to combine two rows, then we can use this product rule. Like you can select steric from the whole, steric is used, is the universal operator that represents that you want to select the entire entities from the students. Here you want to select all the courses that the student have taken. Then we go with that. After that, we have relation joins. These are the queries that you can perform. Like when you create the databases, these are the operations that you can perform here. Just like the select operation, like if you want to select something, then you can use the select operator. If you want to rename something, then you can use this syntax to rename it. So if you want to remove the duplicated data, then you can use the union operator. If you want to find a specific number of entities from the table, then we can go with the difference. If you want to combine the each row with the other one, then we go with the product operator. So these are the syntax that I mentioned here. Now we have relational joins. For example, you want to combine the data from two relations based upon the condition. Then we use the relational joins. For example, then we have another term, the natural joins. So what the natural joins will do, it will joins the two table on the columns with the same number. Let me explain it here. Like for example, you want to select the students as a natural join, the enrollment. So how many students have enrolled from two, like you want to select the students that have marks greater than 800. So this is a specific condition. So there are two tables. There are one table that are the students that are belong from the arts department. We have students that are related to the medical, but we have different categories of students: medical, engineering, IT, arts, multiple departments we have, and we have multiple students for each and every department. But your goal is to select all the students whose GPA is greater than 3. Whether you are not concerned about their department, you just need the student whose GPA is greater than 3 just for the sake of scholarship. So which query you will perform? Here you can perform the natural join. So like when you want to select a specific thing from all the presented columns or tables, then we go with the natural join. Then we have a theta join. Now it will joins the table using a condition other than the equality. Means Instead of equality, you can select for greater than or less than. If I say that only choose a student whose GPA is less than 3 or greater than 4, but is not equals to 3, then we go with the theta joint. For example, here select from the students, S can be the name of the student, and courses, C for the any course you want, where the S age means the student age is equals to the course A required age. Like for example, the student you want to select a specific student from the course. For example, the course is mathematics and the student name is John. Let's say that. You say that select the student, a specific student, S is taken as a variable here. So you don't need to specify uh, a name. So when you write the SQL queries, so this is the syntax that after writing the name of the table, you have to specify a variable for each and every entity. Steric represents that this variable is for all the entities that are present in that student table. So you want to select courses instead of courses, it can be a IT course or whatever it is. You have specified a age group. So they are the students whose age is 18, 20, 23, 24, 25, everything. But the age required for the course is 20. So this is how the theta joint will work, that you said that select the student from the table whose age is greater than 20 but not equal to 20. So this is how you write a specific query in the SQL. So then we have other terms such as we have semi-joints, we have semi-joint. So what the semi-joint will do, it will return the row in the first relation that have matched in the second. Let's suppose, for example, you want to select every student from the student where exists. Let's suppose you have select one student from the enrollment table where the student ID is equals to the enrollment student ID. Now let's suppose we have two merit list. So first list or first table contains the name of the all students who applied for a specific course or for the admission in the course. So this list is for them. Then we have a second table who are selected for the enrollment on the basis of merit. Now you want to select student from here who's who are also selected for the enrollment. So this is the semi-joint. Means you want to gather the data of those students. Means maybe their personal details are present here. Only their ID and the roll number is present in the second table. So you want to gather the data of only those students whose student ID is matched with the student ID in the enrollment. Maybe you have presented their roll number also in this table and also in this table. So you want to get that student. So that is the semi-joint. Means when you want to get the data of the student that is present in both the tables, that is the semi-joint. So if you have any question till now, let me know. So everything is clear. If you want to discuss anything, you can share here. If you have any confusion or question related to these queries, so we can discuss it before moving towards the next. So we have anti-join in SQL queries that will return rows from the first relation without matches in the second. Now let's suppose you want to select all the students who which are not selected for the admission, which are not present in the merit list. So for there you can apply the anti-join. So what is the syntax here? Like you want to select all the students from the student table where not exist a select one, means from the enrollment table where the student ID is equals to the enrollment ID. So you want to select all the students from there. And what is the syntax? Here in semi-join, the exit is used, but here not exit is used. So this is the basic difference between semi-join and anti-join. Then after that, we have deviance. Now, what is the deviance? Means you want to find a tuple in one relation that is associated with the all the tuples in the other. For example, in the we have two tables, one for the student and one for the courses. We have two tables here. Now, maybe multiple students have taken the same course. Maybe we have 20 students in the student table that have taken the CS as their course, the CS subject as their course. They are enrolled in that course. So, what you want to do, you want to find all the rows that have taken this specific course. So, that is the division that will help you to find the tuples in one relation that is associated with all the tuples in another. So the question is, how SQL implement relational set theory? Means till now we have discussed all the operators and all the queries that can be used here. Means we have learned about the select operator. We have learned about how we can rename our name, how we can find a specific term, how we can apply join. So that was the relational set theory. The question is how the SQL, means the structured query language, performs that. Now, for example, SQL select includes the duplicate unless the distinct is specified. Now, this select query may include, for example, you want to select all the students, but this select itself contains all the duplications. For example, in the student table, there are multiple students with the same name. In the courses table, there are two or three courses that are copied multiple times. So the select operator will select each and everything. But if you define distinct with it, then it will define the uniqueness. Let's suppose you want to select the age from the students. Now, what the duplication you will include? Uh, if you want to select age from the student, it will collect all the or select all the ages. But if you specify that don't duplicate 15 or 16, if the students, the number 15 or 16 is multiplied or have multiple or occur multiple times, then don't include it. uh, Maybe in duplication 15 or 16 can be present multiple times. But if you select distinct like this, if you write select distinct age from students 16 or 15, then there will be no duplicates. So this is how the select theory can implement the relational set theory. Now here the distinct plays the role of the union operator. So this is how the SQL implements the union operator with the keyword distinct. Now we have the relational set theories and standards SQLs are not turning complete. How? Now the turning completeness means the ability to solve any computational problem. Means that what kind of problem you give to the SQL set theory, it can solve each and every. But our standard SQL don't have the features like loops and recursion. What are loops? Like maybe in programming you have learned about that. If you want to repeat a specific task for a specific period of time based upon a condition, then we applied loop. For example, if I want to print a specific line 100 times, then that will be a loop. And recursion means that in the recursive manner, until a specific condition is fulfilled, it will perform. Like you want to find the factorial of a number. So it will be find the factorial until its last one is performed. So these are the two things that are not present in the standard SQL. That's why we say that the SQL is not complete. So, but we have extensions like recursive SQL with the recursion. So, with that properties, we can implement that. So, like here, for example, as I mentioned that if you want to find the factorial of a number, then if we apply a set theory with a recursive function, then it will result something like this. It will give you a factorial of the number. But if you use the normal SQL or the standard SQL, then it is hard to find that. So till now, what we have discussed, what things that you should keep in mind, these things like what are entities, what are classes, what are tuples. So these are the major concepts. Then after that, what is the set theory? Means the queries that we try to apply. Means what are the predicates? Like what is the select theory? If you want to select a specific number, how you can select a specific number with the select operator. So if you want to delete something, you can delete it with the delete operator. So if you want the unique data, you don't want to duplicate that, then you can go with the union operator. So till now we have discussed all of these things. So, but the last one was just for the sake of understanding. This one, you don't need, we can go with the distinct keyword to eliminate duplicate rows or tuple. So after that, we have discussed how the relational set theory are not turning complete. Here we have learned about the recursive SQL. Then what is heading and body or the collection of tuple here? So the relation, a table in a database consists of heading, a body, and itself the data. So heading can be define the structure of the table. Here in the heading, we will define the column names and their data types. Like here in the in the example below, the heading is the student ID, the name and the age. And the rest of it is the body of the data that represents the row. Now the body contains the collection of the tuple, like the first tuple contains the student ID 1, the name John, and the age is 15. The second tuple contains the second ID as 2, the name Sarah, and with the age 16. So this is the structure of the relational database. After that, we have attributes. What are attributes? Attributes are the properties. It can be the value, it can be name, or it can be the domain, means from which specific area the entity belongs. So a column in a table represents a property of the entity. Now the attribute can be a name, it can be a age. Now what is a domain? Means a specific set of value. Like we set a condition that the age can be the integer from 0 to 120. Means age will not exceed from 120. It can be 120 or below 120. So that is a specific domain or boundary that you have set. Let's suppose, for example, for the age attribute, you want to the positive integers. We know that the age cannot be a negative number. Can someone have age -1 or -2? So here you want to create a condition. Let's suppose you want to create a table of the student where the student ID will be integer. Integer is a data type. So if you have learned programming, then you have the knowledge about the types of the data. Now, the student ID should always be a positive integer. Then you set the condition that the name of the student will be only 15 characters long. For that, you select the data type varchar, means the variable characters. Then after that, the age, you set the age should be integer, and you set a check the age that is greater than 0. So this is how a table is created. Okay. Then we have discussed about tuples, means the unordered collection of attributes. Then we discussed the relationship of table keys. Now here you have to understand the most important thing. What are the keys? The first thing was the primary key. Mostly I have talked about that. That will uniquely identify each row, like the student roll number. Then we have origin keys, means it will link a row in one table to another table. So for example, just like we talk about the merit list and the student table, you want to get the name of the student who is present in the student table and whose name also appear in the merit list. So here where the origin key will help you, that it will link that student row in the student table and the student row where the student name appear with that table. So this is how the origin key will use for them. So if we take an example here, we have a student table, two tables, student table and enrollment table. The student table, student ID is this, name is John and age is 15. Now in the enrollment table, the course ID means the John whose student ID is 1, whose enrollment ID is this, and the course ID is this. You want to collect these two ones. So this is how the Freudian key will be refer the student ID in the student table. So hope so this concept is clear. Then we have cardinality and RTs. Means these are the attributes in a relation. Like the student relation have three RTs, like the student ID, the name, and the age. Means a column containing a specific attribute. Then cardinalities means the number of the tuples in a relation. Means the student relation has cardinalities. Means there are two rows of the student. So that is its cardinality. Okay. So what is the practical uses of relational database design? Means how and where we can use these relational databases. Means the normalization. What is normalization? Means after database you want to more clean that data. Means you want to reduce the duplication of the data. You want to ensure the accuracy of data. That is where the normalization comes. So in future we will learn more about normalization. Then data integrity means you want to enforce rules. So just to maintain the accuracy of the data. Here you can use primary key that will ensure that there is no duplicate row. You use foreign keys that maintain the referential integrity. Means if one row in one column is referring with the other row in the other table, means two rows are referring with each other, then we go with the foreign key. So that is the flexibility, means in the change in the schema. So this was the introductory lecture where we just have a brief introduction of advanced databases. What are SQL queries? What is normalization? How practically we use the relational database design. In the upcoming lectures, we will discuss normalization in detail. We will discuss how we can normalize the given table, how we can write the SQL queries practically, where we can use and how we can apply it. So if you have any question, you want to discuss something, then let me know.